This benchmark scored 96.7%. That looked excellent. Then, while checking the test split, I noticed something that changed what the number meant. The test examples carried the same hidden source identity as examples in training. Here is the setup. A benchmark is a set of labeled examples used to compare an algorithm. Several examples can come from the same underlying source: one patient, user, device, author, or scene. The algorithm should learn the task signal, not a marker that simply identifies the source. Training examples are available for learning. Test examples are held back until the end, so their score estimates how the algorithm handles the kind of new case it will meet in deployment. I traced that source marker across the boundary. 21 source groups appeared on both sides. So, a test example could have a sibling in training with the same identity marker. The algorithm could recognize a familiar source and use that as a shortcut. The test would reward recognition, even if the intended task signal was weak. I changed one thing: the split. Every source now stayed entirely on one side, so no test source had a sibling in training. I kept the dataset and the algorithm, refitted on the new training partition, and asked the same task again. This is a new fitted model, but it is the same data and method under a different definition of new. The score fell to 62.5%. That drop is the answer to the mystery. The first split had made source familiarity available. The repaired split removed that shortcut and tested transfer to unseen sources. This does not prove the algorithm is bad or that every benchmark is broken. It tells us what the first score was measuring. Before trusting a benchmark, decide what deployment calls new. If the system must handle new patients, users, devices, authors, or scenes, hold out that whole group. If the same groups will recur, a row-wise split may be the right question. The split is part of the experiment, and it decides whether a high score means generalization or recognition.